everyone, welcome to my YouTube channel. In this video I'm going to be going over glycogen storage disorders. First things first, what is glycogen? Glycogen is basically stored glucose. So when we have enough glucose in our bloodstream, all of our glucose is going to go and be stored in this form called a glycogen, which is a bunch of glucose is connected to each other and some branches as well. So when we are low on glucose, we want some glucose to come out of these glycogen stores. And just so you know, I do have a separate video on glycogen metabolism in my YouTube channel, so please check it out for review. So we have this stored glucose in the form of glycogen. When we have low blood glucose, we want to break these apart and get it into the bloodstream so we have free glucose coming into the bloodstream in order to increase our blood glucose. In people with glycogen storage disorders, they are not able to properly break apart this glycogen, so usually they have an overaccumulation of glycogen storage. And that's why they're called glycogen storage disorders. So there are four main types that you should know. Type 1. Type 1 is called von Gierke's disease. Von Gierke disease. This one's a little hard to pronounce. Alright, type 1 glycogen storage disorder, von Gierke disease. In this disease, you are going to have a deficiency in the enzyme glucose 6-phosphatase. You're going to have a deficiency in glucose 6-phosphatase. What does this mean? You can't break apart your glycogen because we know if it has the word tase in it and it involves breakdown. And if you can't break that down, that means you're going to have a lot of glycogen in your liver and your kidneys. And something that presents in von Gierke disease that does not in the other four glycogen disorders, or glycogen storage disorders, is something called lactic acidosis. There's too much lactate. And why is that? That is because glucose 6-phosphatase, this should sound familiar too because this is an enzyme involved in gluconeogenesis. And it's going to allow us to go from glucose 6-phosphate to glucose. Please excuse my air conditioner that just decided to turn on in the background. So we're going to go from glucose 6-phosphate to glucose via the enzyme glucose 6-phosphatase. Now let's think about it. If we have deficient glucose 6-phosphatase, that means that gluconeogenesis cannot completely occur. So we're going to have a buildup of our reactants for gluconeogenesis, or our previous substrates that are before this step, we're going to have a buildup in those. And that is going to also cause a buildup in pyruvate, because we know in gluconeogenesis we are going from pyruvate to glucose through all of these steps. This step, which is one of those, if you're not able to complete gluconeogenesis, that means you're just going to have a buildup of the substrates that are starting off this process. So we're going to have a buildup of pyruvate, and that excess pyruvate is going to become lactic acid. And that's why we're seeing lactic acidosis. And another symptom that you should associate von Gierke's disease is gout or excessive uric acid. It's not being depleted properly. Excessive uric acid. And a way to remember this is that von Gierke's disease has a G in it. The G is for glucose 6-phosphatase. The G is also for gout. And the G is also for impaired gluconeogenesis. So that's how you can remember which one von Gierke's disease is. Alright, let's move on to type 2. The type 2 glycogen storage disease is called Pompe disease. Again, please excuse my pronunciation, Pompe Disease. Now, the deficient enzyme in this disease is going to be alpha 1,4-glucosidase. And this is what allows lysosomes to break apart glycogen. Another word for this is also acid maltase. And actually it should be called lysosomal acid alpha 1,4-glucosidase, or acid maltase. And this is what allows for glycogen breakdown in lysosomes. Now, if we are deficient in this enzyme, that means we're going to have glycogen buildup in lysosomes. So we're going to have glycogen buildup, and the main symptoms are cardiomyopathy, and exercise intolerance. There can be, well, these are the main ones that you should know. And the way that I like to remember this one is that I imagine that we are pumping a bunch of glycogen into the lysosomes. Obviously, that's not what's happening here, but there's just, the lysosomes are getting pumped up with this glycogen and it's not coming out. So I just think of lysosomes pumped with glycogen. So you know that the lysosomes are involved. And to remember the exercise intolerance, I like to think of Pompeii. If you know, Pompeii is where the Mount Vesuvius volcano is. And I just think of me trying to climb up that entire volcano and how I would be very intolerant to that type of exercise because that is way too much work. Pompeii, try to climb up that huge volcano, you're going to get intolerant. So that's how I remember exercise intolerance. All right, type 3. Type 3 is called Cori disease. Which enzyme is deficient in this disease? The deficient enzyme is called the D-branching enzyme. And we know that the D-branching is done by alpha 1,6-glucosidase. We know that it's 1,6, not 1,4, because 1,6 are the branches. Remember, 1,6, there's a branch into the mix. And the way that I remember to associate Cori disease with debranching is that I like to think of Cory Booker, who is a senator, and he was also a presidential candidate at some point, I think. I just imagine him doing a press debrief. Debrief for debranching. So Cori disease is associated with the deficiency in the debranching enzyme alpha 1,6-glucosidase. And in this disease, the main thing that you should be able to identify is an increase in something called limit dextrins. Now, when you're not able to remove the branches of glycogen, you're left with these little remnants, and those are limit dextrins. So you're going to have an accumulation of these limit dextrins, and this accumulation can lead to hepatomegaly, which means an enlarged liver, and also cirrhosis, which is liver damage. So that's basically what you need to know for Cori disease. All right, one more. We are going to go over type 4 or type 5. There are 5, but you only need to know 4 as of now. And this is going to be called McArdle's disease, or just McArdle disease. This disease is caused by a deficiency in the skeletal muscle glycogen phosphorylase. Okay, phosphorylase means to break, right? And if it's in the skeletal muscle, it's called myophosphorylase. The M in McArdle matches up with the M in myofosforylase, which also matches up with the M in muscle. So in this disease, patients are going to present with muscle cramps, myoglobinuria, which is basically red urine. And there's an M in there, there's an M in muscle cramps, there's an M in myofosforylase, and there's an M in McArdle. And another symptom is arrhythmia, and another symptom is the second wind phenomenon. And this is commonly noted during exercise. So I found myself getting confused between McArdle disease and Pompe disease, or Pompe, however it's pronounced, because they both kind of involve exercise. But Pompe disease does not involve the skeletal muscle the way that McArdle disease involves skeletal muscle glycogen. And Pompe does not have an M in the beginning, it has a P in the beginning, so we're going to just associate that with pumped lysosomes with the glycogen. And McArdle, since it has the M right in the beginning, we're going to associate that with muscle cramps, myoglobinuria, second wind phenomenon during exercise, and myofosforylase. Okay, so those are 4 of the glycogen storage disorders. I know that there's 5 ones, but these are the 4 main ones that we'll be going over today. I hope that was helpful. Please let me know if you have any questions or concerns or advice in the comments.